Hello, everyone. I'm Jonathan, and welcome to another episode of Ventev Connected Voices. I'm joined by my co-host Jared, who is our resident technical protagonist. In today's episode of Connected 30, we have Dennis, who is our product line manager for antennas. So Dennis, we're here today to talk about leveraging Ventev for complex Wi-Fi designs. Can you walk me through some examples of challenging Wi-Fi designs?
Yes. First of all, thanks for having me on. Yeah, so when we're talking about Wi-Fi designs, there's always some types of challenges that come up. So, for instance, let's talk about Wi-Fi 6E, since Wi-Fi 6E is like the major buzzword going on right now in the industry, right? So one of the challenges with 6E is mounting, right? So how do I mount a Wi-Fi 6E access point and make them look appealing in an environment that they're being placed in? That's one of the questions that we're always getting.
So you mentioned ceiling tiles. What are some ceiling tile solution applications?
Yeah, there's numerous applications for ceiling tiles. We could talk about healthcare, right? So one of the healthcare's top priorities is protecting their patients, right? And a large part of that includes avoiding exposure to the area above the ceiling. You know, above the ceiling, you have dust, mold, and fungal spores, and those pose risk to patients, right? So the way that our ceiling tile enclosures are designed, we have interchangeable doors, which enable our customers to access their access points without exposing the area above the ceiling. And then therefore we can prevent exposure to the patients from that aspect. Another application, for instance, is education. We know campuses have many buildings of various ages and building styles and materials. So for each type of style, each type of building, there may be something different that hinders a specific type of tile being placed or being used, right? So it's very essential to have different types of mounting options based on the different styles that these buildings have in education.
You bring up the improvement in health among healthcare, but these are a little bit heavier than a regular ceiling tile. How do you handle that?
One thing about our ceiling tile enclosures, they're made of aluminum, so they're not as heavy as the current ceiling tile grids, and therefore they won't hang once they're put in place. And then also we have attachment points on the back side of these ceiling tiles to connect to the superstructure of the building.
Yeah, we actually had those certified out of the state of Alaska for OSHPD certification, or Occupational Safety and Health Administration, in relation to potential earthquake, to assure that those didn't come down and, hit the kids or the patients in the head, right?
That's true. And then another application where our ceiling tiles are used is in the enterprise space. We know that right now aesthetics is a big thing with a lot of the buildings, and they have requirements that limit the ability to mount an access point. Some of them don't want them directly on the ceilings. They don't want to use the actual grids that come with the access points for mounting. So our ceiling tile offer provides a variety of solutions that can meet the needs of both the facilities team and the networking team.
So I know you mentioned Wi-Fi 6 earlier as well. What about Wi-Fi 6E from an antenna perspective?
That's one of the really challenging aspects of Wi-Fi 6E right now. So we know currently Wi-Fi 6E, all of the access points that are currently being shipped, and in particular the ones that we kind of just briefly mentioned as far as for the ceiling tile enclosures that we have to support those 6E APs, those are specific to APs that have internal antennas in it. One of the challenges that we're seeing right now directly in response to Wi-Fi 6E is a challenge of future-proofing the Wi-Fi refresh deployment using external antennas when it's still up in the air, as far as when the FCC is going to allow 6E access points with external antennas to be released or used.
Then why would I want to order an antenna for a spectrum that's not yet approved for use on an external antenna access point today, Dennis?
The spectrum is approved. It's just that the antennas for use with external connectors on those access points has not been approved by the FCC.
And that's because I can't control the power output or the dBi gain.
So, Jared, it's not necessarily that the frequency haven't been approved. The frequencies have been approved for operation. The problem is that there are incumbents that currently use that frequency band. So therefore, what the FCC is trying to do is they're trying to make sure everyone plays happy in the band with Wi-Fi, which is unlicensed, and then the incumbents that are currently in that band. And the way that the FCC is doing that is something called automatic frequency coordination. And what that is it's a tool that determines the technical characteristics of an incumbent service currently used in the band, and also determine the necessary power levels and frequencies for a standard AP at a given location. So when we're talking about Wi-Fi 6E, let's kind of go back and kind of detail what the different types of devices will be in 6E, right? So what we have is low power indoor devices. These are those devices specifically that have internal antennas. And with these devices, the EIRP, or the effective isotropic radiated power, is 18 dBm at 20 megahertz, which is the channel bandwidth, 21 dBm at a channel bandwidth of 40 megahertz, and 24 dBm at a channel bandwidth of 80 megahertz. And this is indoors, so you have to use internal antennas. Now, at these power levels aren't high enough to interfere with what's currently operating in these frequency bands or these incumbents. So therefore, there's no issue where you would need AFC. Now,
so a dBm, okay, that's a Dennis Burrell milliwatt.
Yeah, if you want to call it that, but no, it's actually a dB per milliwatt. So now, for standard power, the effective isotropic radiated performance is going to be 36 dBm. So that's much higher than the low power for indoor. And standard power is for your outdoor and indoor operations where you need a higher power level, right? Now, this is where the interference comes into play with the incumbents. So therefore, that's why the FCC is working to finalize and approve this automated frequency coordination, or what they like to call AFC. Once this is ratified, or once this is approved, then all of the AP manufacturers will be able to start selling their APs, their 6E APs that have external connectors on it to use external antennas. Now, until then, you still have a lot of companies, a lot of enterprises that want to upgrade their Wi-Fi systems that they currently have. So that challenge that I mentioned earlier about future-proofing is to actually come out with antennas that currently support the 6E band, although the 6E band isn't being used with external antennas. And that's one of the things that we've been working on and doing as far as releasing some of our antennas. We have a line of our antennas that are what we call 6E capable, although 6E can't be used as of now with antennas, external antennas.
But it's not that far off, right?
No. They're saying I would say probably mid next year, maybe late Q1 or Q2 of next year, where hopefully the FCC will approve AFC and we'll start seeing access points being sold where you can use external antennas on them. Now, I mentioned a little bit about some of our antennas that are currently 6E capable. I want to talk a little more specific about some of our antennas. We have what we call our small form factor line of antennas. And basically what that is antennas that we've come out with, or we've been constantly improving, trying to think outside the box to make these antennas smaller and smaller. Our original 6 dBi antenna design, for instance, was pretty much a 9 by 9 inch form factor as far as the radome or the footprint of the antenna. With our small form factor of line of antennas, we've taken that down to where our newest antenna, which is 6E capable, which we call our femto patch antenna, is 3.4 by 3.4 inches. So we've effectively decreased our footprint of our antenna, our directional antenna, threefold. And it's still a 6 dBi gain antenna.
Are there any other antennas we're currently looking into, Dennis?
Yes. So outside of our femto patch antennas, we're currently looking at doing 6E designs for some of our higher running antennas and all of our antennas that are equivalents to all of the major major AP manufacturers' antennas, whether it be Cisco, Aruba, Meraki, Mist. We're working on antennas that support 6E for all of those AP manufacturers.
Thanks for that, Dennis. Are there any other challenges you'd like to discuss dealing with Wi-Fi designs?
One of the things that we've come across as well that's big for us now is aesthetics, right? And that challenge is providing Wi-Fi in an aesthetically pleasing environment where everything needs to be hidden. So we're always constantly being asked about small form factor, whether it be small form factor or any types of antennas or mounting solutions where we can actually hide the Wi-Fi. From a mounting solution perspective, that's where our co-location mounts come in, where we actually can locate the antenna and the access point, and then the cables of the antennas are hidden so that you don't see cables all over the place. So that's one thing that we've done. Another design that we're really proud of is our raised access floor Wi-Fi antennas. So what these are our antennas where we've actually taken raised access flooring and we've embedded our antennas into them. Now, let's think about this. So we've gone from a top-down approach as far as the access point on the ceiling with the antennas or external antennas on the ceiling transmitting down to the client device to what we call a bottom-up approach where the antenna is actually in the flooring and now the antenna is transmitting up to the client device. Now, the difference between the two is that, for one, the antennas are closer to the client device now, being from a bottom-up approach from the floor, as opposed to a top-down approach where the access point in the antenna is on the ceiling. Now, with this bottom-up approach and using raised access flooring, the access point is actually below the floor, connected to the antenna, and then the antenna is part of the actual raised flooring now. And once the covering of the flooring is used, whether it be carpet, tile, wood, in some cases, once that's placed over the antenna, you have a totally aesthetically pleasing solution where you don't see anything. Wi-Fi is there, but it's hidden.
So, Dennis, that's great. We can now look at a bottom-up and a top-down approach to covering different spaces with a very pleasing aesthetic eye. But you mentioned Wi-Fi 6E and, again, antennas in the floor tiles, when virtually all of the Wi-Fi 6E, well, every one of the Wi-Fi 6E access points being shipped today are internal antenna access points. How would you handle that in a bottom-up approach?
So let's look at that from two aspects. One from just the Wi-Fi 6E approach, right? So we mentioned a little earlier about future-proofing design such that Wi-Fi 6E is designed into the antennas that we currently have, right? So we've actually done some designs. Some of our designs for our floor tile antennas are actually Wi-Fi 6E capable. So from the aspect of future proofing, if someone wants to put in or use our raised access flooring now in hopes of transitioning to Wi-Fi 6E at a later date. And by the way, we do have some customers that have done this already. We have a floor tile that's 6E capable. So instead of a dual band 2.4 and 5 gig design, we have a tri-band design, 2.4, 5, and also 6 gigahertz, which covers that 6E frequency spectrum. Now, to the point where we're talking specifically about current Wi-Fi 6E access points with internal antennas, we've actually come out with a new raised access floor design, which we call our RF-friendly floor tile. And what this design is it actually a raised floor tile using a concrete raised floor panel, where we've actually cut out some of the steel on the back side of the floor tile, where we have what we'll call RF-friendly windows, where there's no metal and there's actual windows cut out into it so that we can actually transmit and receive through the concrete. So now we have a design where we can actually use 6E with internal antennas and place that under the flooring and still be able to transmit and receive through the floor tile. Now, one thing about these windows, they're set up so that it's in a 3x3 design, square design, where these windows are 3 inches by 3 inches as far as their size. And so they're a total of nine windows, each of them 3x3 inches on the bottom side of the raised floor.
So talk about future proofing. I can not only change out the door in the ceiling tile enclosure to change out access points, but with this new floor tile, I can look at doing the same thing under the floor. That's like magic.
Yeah, exactly. I wouldn't specifically say magic, that word, but a lot of people think that RF is magic anyway. So I guess I could take that. But the magic in this design is the radiation of the antenna through the flooring. Now, the reason why we specifically selected 3x3 inch windows is because you want to be able to transmit at a half wavelength of the frequency of operation. And at the frequency of operation of 2.4 gigahertz, the half wavelength is somewhere on the order of around 2.6 inches. So therefore, you can transmit through these windows. Now, I know we're talking dual band and tri-band designs now, but since 2.4 is the lowest frequency being used, that's going to have the longest half wavelength. So 3.3, the 3 inches allows for that transmission. And if it allows for that transmission at 2.4, it also allows for the transmission at 5 and therefore 6 gigahertz as well.
That's great, Dennis, but how do I handle different access points when I'm trying to mount them under these windows in the floor?
We've actually come up with a adjustable access point tray in which all of the different manufacturers' access points can fit into this tray. Now, the thing with this tray is that it's adjustable up under the bottom of the floor tile with the cutout windows. So you can adjust it to the point where you can actually fine tune or maximize the performance of the specific access point in relation to the distance between the access point and the RF window or the RF friendly windows on the bottom of the floor tile.
The next whiz-bang thing everybody wants to talk about is 5G and private LTE. What's Ventev doing in that regard right now, Dennis?
Yes, that's another one of the buzzwords, right? You have Wi-Fi 6E, and then you have 5G, and 5G not to be confused with 5 gigahertz, but actual LTE, private LTE solutions. So we've been getting a lot of questions into 5G antennas and accessories, and what I would like to say is that although Ventev is predominantly known as a a provider of Wi-Fi solutions, Wi-Fi accessories, a Wi-Fi ecosystem provider, we've started to branch out and actually increase what we're doing in the 5G space as well. So now you could say that we are also a 5G ecosystem provider, right? So we have our antennas, we have broadband antennas covering not only 5G, but LTE and CBRS. We also have passive accessories as well for those frequency range. And we have a whole host of mobile and actually industrial IoT antennas as well to support these frequencies.
I want to thank the both of you for joining us today. You can find more information by going to ventevinfra.com, or you can request more information by emailing sales@ventev.com. Thank you both again.